Okay, so we looked at the bug problem, which put two and then a third line on the same on the same coordinate plane, and then we looked at the tree problem, which looked at two lines on the same graph. And what we were introducing there was a system of equations. A system of equation is two or more equations with the same variables. Now, you, since about sixth grade, have been looking at one equation with one variable. We are going to, in Algebra 1, look at two equations with two variables. When you get into Algebra 2 and some higher math in high school, you'll do three equations and three variables and four and four. You will learn how to use matrices to solve this, and you will be doing my favorite, absolute favorite part of math, which is called linear algebra. But we're going to start pretty basic, okay? They're going to give us two linear equations. We look at this, we recognize this as two lines in slope-intercept form. And our first step is to graph both equations. So I'm going to graph y equals 3x minus 4 first. Your points here are going to be more important than how pretty your line is, especially you know how mine are when I graph. So make sure you make points that you can see very well. And I also suggest that you cover as much of the graph as you can, that you go from edge to edge. And that way, there won't be any question about where the two lines intersect. Okay, so here is my first terrible line. Okay, and now we're going to graph the second one. The second one is y equals negative 1/2 x plus 3. So my y-intercept is 3. My slope is negative 1/2. Notice I see a point of intersection. I'm going to go past it. I want to see the x, okay? I want to see where those two lines cross. Don't be stingy with your lines. Make sure that the intersection is obvious. So where do these two lines intersect? Well, they intersect right here, and that is the point 2, 2. So the point of intersection is called the solution to the system. The point of intersection is what we are looking for. Where do these two lines intersect? So we're going to verify that this point, 2, 2, is a solution. Now, a solution means it makes an equation true. So we're going to plug 2, 2 into both equations, and we're going to show that it makes both of them true at the same time. Now, this one's a little weird because it's got the same x coordinate and y coordinate, but the x coordinate is 2, the y coordinate is 2. So for y, I'm going to plug in 2 equals 3 times the x coordinate is 2 minus 4. So this is 2 equals 6 minus 4. And guess what? That's a true statement, right? 6 minus 4 is in fact 2. So 2, 2 is a solution to the first equation, and that means it's on that line. If it is a solution to that equation, it is on the line. Now, let's plug it into the second linear equation, y equals negative 1/2 x plus 3. My y coordinate is 2 equals negative 1/2 times my x coordinate is 2 plus 3. So let's see if this is true. Negative 1/2 times 2 is 1. I'm sorry, negative 1. And negative 1 plus 3, guess what that equals? That equals 2. So since this point makes both equations true, that means it's a solution to that system. And the way that shows up by graphing is it's the point of intersection. That point is on both lines at the same time. Now, we're not going to have to do that every time. We do not have to plug it in and show that it makes both true, but know that you could. You could verify your answer by plugging it into both equations and showing that it makes both of them true. Sometimes it's going to be as easy as here are two lines that are intersected that are graphed on the same coordinate plane. Tell me what the solution is. Where do these two lines intersect? So you're going to look for that point of intersection. It's right there. And you're going to give me the solution as an ordered pair. These two lines intersect at the point 3, negative 2. Okay, look over here. Here's another system. This is two lines on the same graph, and I want you to tell me the solution to that system. Where do those two lines intersect? Hopefully, you saw that that's the point of intersection and it has coordinates 1, 3. You don't have to circle it every time. I'm just circling it since we're learning this so that you know exactly what we're looking at. Now, you know they're not always going to just put two lines on the same graph and say, where do these intersect? Sometimes we're going to have to graph them ourselves. Okay, so here's the line y equals 1/3 x minus 3. So I want you to graph that line on this coordinate plane. Your line should look like mine. Remember that, especially with that first line, fill in as many points as you can so that you don't have to guess on that point of intersection. Okay, now I want you to graph the line y equals negative x plus 1. Make sure your line has negative slope. I didn't have to do the whole graph because once I saw where they intersected, I just needed to go past there. I want to see the definite x, okay? Where do these lines intersect? They intersect here. That's my solution. And the coordinates of that point are 3, -2. Let's do another one. You graph the line y equals 3x minus 3. Check yours, check mine, make sure that they match. And now graph the line y equals 1/2 x plus 2. Make sure your line is correct. And now tell me the solution to this system. The solution to the system is the point 2, 3, because that is the point that is on both lines. Okay, there are two special things besides intersecting that can happen when you have two lines on the same graph. They can intersect, you can have a solution. But let's see what happens in two other cases. So I want you to, first of all, graph the line y equals 3x plus 5. That one you had to be a little tricky. There wasn't room to go up 3 and right 1, so you had to go back 3. I mean down 3 and left 1. So there is the line y equals 3x plus 5. Now graph the line y equals 3x minus 2. Check your second line. What do you notice? These do not intersect. Is there any point that is on both lines? There is not. So when they do not intersect, we say that there is no solution. There is no point that is on both lines. What kind of lines are they? What kind of lines never intersect? Parallel lines, right? Now, a couple things to look for. Notice they both have the same slope. Does it make sense that if they have the same slope, they're going to be parallel and not intersect? Possibly. They have the same slope and they have different y-intercepts, right? So they're going the same direction, but they start at a different place. So that will have no solution. Okay? The other special case, you graph the line y equals -2x plus 3.